I could say that it's not a wreck, it's something that looks very odd. Then we start measuring it and saw that it's nearly 60 meters in diameter.
In June 2011, a grainy sonar image from 87 meters beneath the northern Baltic Sea ignited one of the internet's most electrifying mysteries. A 60-meter wide circular formation, a strange 300-meter track leading toward it, and rumours of malfunctioning equipment above the site. The discovery by the Swedish exploration team, Ocean X, spread globally within days, but after expeditions, rock sampling, and geological analysis tied to Scandinavia's Ice Age history, scientists have finally solved the Baltic Sea anomaly. The truth changes everything. The discovery that shocked the Baltic. On June 19, 2011, the Baltic Sea was calm and grey along the northern reaches of the Gulf of Bothnia, between Sweden and Finland. This stretch is best known for shipwrecks. Down below, at roughly 85 to 90 meters, the seafloor sat in near freezing darkness, coated in fine sediment shaped by the last ice age. Up above, a small Swedish exploration vessel moved slowly across the surface, towing side-scan sonar in long, methodical lines. On board was the team from Ocean X. Ocean X is a commercial exploration group founded by Peter Lindberg and Dennis Asberg. They specialize in locating valuable cargo from historic wrecks, champagne shipments, metal ingots, and artifacts lost in wartime sinkings. The Baltic is ideal for that kind of work. Its low salinity and oxygen-poor waters dramatically slow decay. Historians estimate that more than 100,000 wrecks rest beneath its surface. For treasure hunters, it's less a sea and more a submerged archive. That June expedition was routine. The vessel crawled forward, sonar fish trailing behind, emitting fan-shaped pulses of sound that swept the seabed and returned echoes to a monitor in the cabin. Most returns were dull. Ripples of sand, scattered rock, the occasional debris field. The crew had seen it all before. Then something appeared. On the monochrome sonar screen, a shape materialized. This was not a shipwreck. It was not elongated. It did not look fractured. It looked circular, broad, distinct. The early measurements suggested a diameter between 50 and 60 meters, roughly the wingspan of a commercial jet, or about 180 to 200 feet across. It sat alone, resting on the seafloor at nearly 90 meters depth. They marked the coordinates, labeled it, moved on. At that moment, there was no panic. Experienced operators know the seabed can play tricks. Glacial erratics, which are massive boulders transported by ice sheets more than 10,000 years ago, are common across Scandinavia. Sonar can exaggerate symmetry. Shadows can create illusions of edges and structure. The ocean floor is full of strange geometry, but when the team returned to land and processed the raw data more carefully, enhancing contrast and refining the image, the shape became more striking. The object appeared almost disc-like, rounded edges, a raised central portion, a shadowed perimeter that suggested depth. In a single still frame, stripped of context, it looked eerily engineered. The story could have ended there, as just another curious formation in a heavily glaciated basin. Instead, it exploded. Within weeks, images of what would become known as the Baltic Sea anomaly began circulating online. The internet did the rest. Comparisons were immediate and breathless. The Millennium Falcon, a crashed flying saucer, an underwater UFO. Some began using the term USO, which stands for Unidentified Submerged Object. Media outlets across Europe and beyond picked up the story in mid to late 2011. Headlines leaned heavily into the mystery. The fact that the Baltic Sea is geologically complex only deepened the intrigue.
After sightings of something suspicious in the Baltic Sea.
The Gulf of Bothnia lies atop the ancient Fennoscandian Shield, one of the oldest geological formations in Europe, composed largely of granite and gneiss, billions of years old. There is no modern volcanic activity there, no tectonic drama, just cold, stable crust shaped by ice. And yet here was this circular feature. The depth added tension. At 85 to 90 meters, divers operate at the edge of recreational limits and firmly within technical diving territory. Water temperatures hover just above freezing for much of the year. Sunlight does not reach the seabed at that depth in the turbid Baltic. Visibility can drop to a meter or less. It is a hostile environment. Silent, pressurized, dark. Ocean X announced plans to return in 2012 with more advanced equipment. Multi-beam sonar for detailed mapping, remotely operated vehicles with high-definition cameras, and professional divers capable of descending into the cold, black water. But in 2011, all the world had was that single, haunting sonar image. But it's important to remember that the image was essentially sound translated into shadow. Side-scan sonar does not produce photographs. It produces acoustic interpretations of surface texture. A slight elevation can cast a long, dark acoustic shadow, exaggerating height. The Baltic has seen warships from the 17th century preserved in near-perfect condition. It has cradled German and Soviet wrecks from the Second World War. It has a hidden history in layers of grey mud, so when a circular formation emerged from sonar data in the Gulf of Bothnia, it did not feel impossible that something extraordinary might be down there. And that was the spark. This was enough. Enough to ignite debate. Enough to send divers back into freezing water. Enough to transform a routine survey into an underwater mystery of the decade. The alien narrative. By 2012, the object on the floor of the Gulf of Bothnia had already acquired a mythology. Online forums lit up. Commentators began referring to it as a runway. Others called it a skid mark. The implication was clear. Something had come in at speed, torn across the seabed, and slammed to a halt. The Baltic Sea basin is heavily shaped by the last glacial maximum, which ended around 10,000 to 12,000 years ago. Massive ice sheets covered Scandinavia. As they advanced and retreated, they dragged rock across bedrock and seabed alike. Icebergs carving into the ancient Baltic ice lake could gouge long, straight scours into soft sediment. Marine geologists have documented iceberg plow marks in many northern seas that stretch hundreds of meters. In the summer of 2012, Ocean X returned to the coordinates. The conditions were harsh. At nearly 90 meters, the pressure is close to 10 atmospheres. Water temperatures hover just above freezing. Visibility is often limited to 1 or 2 meters due to suspended sediment. Divers later described the formation as uneven, with ledges and vertical surfaces. Some reported shapes that appeared angular. They spoke of steps or corridors. The language was cautious at first, observational. But once filtered through interviews and headlines, those words hardened into something else. Walls, geometric structure, artificial edges. And then there were the electronics. Members of Ocean X reported that during parts of the 2012 expedition, equipment malfunctioned when the vessel hovered directly above the object. Satellite phones allegedly lost signal. The cameras experienced interference. Some lights flickered or shut down. According to statements from the team, systems returned to normal once the ship moved roughly 150 to 200 meters away. That detail detonated online. An invisible 200-meter dead zone. An energy field. Dormant propulsion. But you see, there are some complications here. Marine electronics can fail for many reasons. Saltwater corrosion, power fluctuations, signal obstruction at sea, satellite connectivity gaps at northern latitudes, interference from onboard systems. None of that is dramatic. None of it trends on social media. By late 2012, the story had detached from its technical roots. International media outlets framed the narrative with escalating intrigue.
Swedish media says the search started after an emergency radio transmission in the Baltic are in trouble.
Comparisons to spacecraft proliferated. The disc-like sonar image was placed side by side with science fiction icons. Headlines asked whether a UFO had crashed in the Baltic thousands of years ago. Some commentators speculated about Nazi secret technology. Others leapt straight to extraterrestrials. The pace was relentless. A routine sonar anomaly discovered on June 19, 2011, became a global mystery within months. YouTube analyses dissected every pixel of the original scan. Television documentaries added ominous music and shadowed recreations, and with each retelling, uncertainty was replaced by suggestion. There was a circular sonar image. There was a linear feature in the sediment. Divers did observe unusual shapes. Equipment problems were reported. Each element is real in isolation, but thriller logic thrives in the gaps between them. No metallic hull was recovered. No artificial alloys were confirmed. No propulsion system was documented. The scientific investigation and rock analysis. The first close-range footage of the Baltic Sea anomaly was less cinematic than the viral sonar image that had circled the globe. What the cameras showed was a rock formation rising from the seabed, irregular in shape, dark in color, with fractured surfaces and uneven edges. Some areas appeared flattened, others sloped. There were ridges and depressions. Nothing glowed. Nothing moved. Divers reported that the object felt solid and rocky, not metallic, not hollow, not manufactured. Using chisels and hammers, they removed fragments of the formation and brought them to the surface for laboratory analysis. The samples were sent for examination by geologists, including researchers affiliated with Stockholm University. Petrographic analysis, which is the microscopic study of rock composition and texture, would determine whether this was engineered material or something far older. The results were not sensational. The samples consisted primarily of common regional rock types. Granite, gneiss. Other lithologies are consistent with the Fennoscandian Shield, the ancient geological foundation underlying much of Sweden and Finland. These are rocks formed hundreds of millions to billions of years ago through natural igneous and metamorphic processes. They are exactly what one would expect to find in a basin shaped by repeated glaciation. Some fragments were described as resembling basalt or volcanic rock in texture, but basalt itself is a common terrestrial rock formed from cooled lava. Its presence is not evidence of a spacecraft. More importantly, nothing in the mineral composition indicated artificial processing. No exotic alloys, no composite materials, no refined metals inconsistent with natural formation. Microscopic inspection did not reveal machining marks. No symmetrical drill holes, no structural fasteners, no manufactured components embedded within the stone. The grain structures, mineral inclusions, and fracture patterns matched naturally occurring rock. No verified measurements demonstrated an active electromagnetic field. No instruments recorded sustained radiation beyond normal marine background levels. No advanced propulsion system was uncovered. The formation did not contain hollow chambers or internal machinery. It did not respond to sonar with metallic echoes. It did not behave like wreckage. It behaved like a rock, and that may be the most important twist of all. The Ice Age explanation. So, what is the Baltic Sea anomaly? Well, it does not descend from the stars. To understand it, we have to rewind the clock not decades, but tens of thousands of years to a time when Northern Europe did not look anything like it does today. The Baltic Basin, now a semi-enclosed sea, bordered by Sweden, Finland, Estonia, Latvia, Lithuania, Poland, Germany, and Denmark, was once entombed beneath a vast sheet of ice. During the last glacial maximum, roughly 20,000 years ago, the Fennoscandian ice sheet stretched across Scandinavia and deep into northern Europe. In some areas, it reached thicknesses of up to 3 kilometers. Imagine a mass of ice so heavy it pressed the Earth's crust downward by hundreds of meters. That ice did not sit still. It moved, slowly, relentlessly, grinding bedrock beneath it, plucking boulders from mountains, dragging entire landscapes southward. By around 11,700 years ago, at the end of the last ice age, the climate warmed. The glaciers began to retreat. As they did, they left behind scraped rock surfaces, gouged channels, transported boulders known as glacial erratics, and thick blankets of sediment. The Baltic Basin itself went through multiple stages: the Baltic Ice Lake, the Yoldia Sea, the Ancylus Lake, and eventually the Litorina Sea. Each phase reshaped the seabed. Fast forward to June 19th, 2011. The anomaly sits at the bottom of the sea. It is approximately 60 meters in diameter, round, symmetrical, with what appears to be a 300-meter linear feature trailing behind it. To the human eye, primed by decades of science fiction, it resembles a crashed spacecraft. That track is in itself one of the most cited mysteries, a 300-meter line carved into the seabed leading toward the object. Was it a skid mark, an impact trail, something descending from the sky, but glacial geology offers a far less cinematic and far more powerful explanation. When glaciers advance, they act like conveyor belts. Rocks frozen into the base of the ice scrape along the bedrock below, carving striations, which are long, linear grooves that can extend for hundreds of meters, even kilometers. In Sweden and Finland, exposed bedrock still bears these parallel scratch marks today. Underwater, those same processes left their imprint on the Baltic seabed. Glacial erratics, which are massive rocks transported far from their origin, can weigh thousands of tons. Some erratics in Scandinavia measure over 10 meters across. When ice melts and drops these stones, they land wherever gravity dictates. Some settle gently, others plow into soft sediment, leaving furrows. If an iceberg breaks off and drifts, its submerged keel can scour the seabed, carving long, linear tracks. This process, known as iceberg scouring, has been documented extensively in Arctic and subarctic waters. In sonar imagery, especially at lower resolutions, natural formations can appear deceptively geometric. Side-scan sonar works by emitting acoustic pulses and interpreting their return. Hard surfaces reflect differently from soft sediment. Shadows exaggerate edges. Slight variations in elevation can look like steps, ledges, or angular walls. When Ocean X returned in 2012 with divers and remotely operated vehicles, samples were collected. Geologists later identified common Baltic region materials. Granite, gneiss, and other crystalline rocks formed hundreds of millions of years ago during the Precambrian. These are the same rock types that dominate much of Sweden and Finland's bedrock. Granite fractures along joints. Gneiss, with its banded structure, can weather into blocky shapes. When glaciers shear across such rock, they can plane surfaces smooth, leaving flat platforms and abrupt edges. Underwater, partially buried by sediment, these formations can look startlingly artificial. The Baltic Sea itself is shallow by global standards, with an average depth of about 55 meters and a maximum depth of 459 meters. In the land-sought deep, its seabed is a patchwork of glacial till, sand, clay, and exposed bedrock. Post-glacial rebound, which is the slow rising of land after the weight of ice is removed, continues even today in Scandinavia at rates of up to 9 millimeters per year. The entire region is geologically dynamic. Critically, no evidence of impact was found. No shocked quartz, which forms under extreme pressures during meteor strikes. No melt glass. No high concentrations of iridium, often associated with extraterrestrial impacts. And no atmospheric entry debris field. An object entering Earth's atmosphere at cosmic speeds would leave unmistakable signatures, such as heat alteration, fragmentation, and blast effects. None were documented at the site. Instead, what scientists see fits cleanly within the established glacial history of northern Europe, a rocky outcrop, likely sculpted and repositioned during the last glaciation. Linear grooves consistent with ice movement or iceberg scouring. Sediment accumulation shaped by currents in the brackish Baltic waters. This changes everything. Well, as it turns out, the real story is not about aliens. It is about how modern myths are born. Side-scan sonar, the technology that produced the original image, works by sending acoustic pulses toward the seabed and recording their reflections.
And we have lots of pictures of the Baltic Sea anomaly. But this picture, I think, is very interesting.
Hard surfaces bounce sound differently than soft sediment. Shadows exaggerate contours. At lower resolutions, small variations can appear dramatic. In 2011, the publicly released sonar image was limited in clarity. Yet, within days, online forums had dissected it pixel by pixel, drawing lines, outlining shapes, circling structures. Humans are pattern recognition machines. The same cognitive system that helps us identify faces, read expressions, and navigate environments also fills in gaps. Psychologists call it pareidolia. This is the tendency to perceive meaningful patterns in ambiguous stimuli. We see animals in clouds, faces on Mars, and sometimes spacecraft on the ocean floor. The Baltic Sea anomaly shows us just how low-resolution data plus imagination equals amplification. Within weeks of the discovery announcement in June 2011, international media outlets were running features. Television crews travelled to Sweden. Documentary channels framed the site as one of Earth's greatest unsolved mysteries. Ocean X members reported temporary electronic disturbances during dives, such as cameras malfunctioning and satellite phones cutting out. Such reports added narrative fuel. Electronics fail underwater for many mundane reasons: pressure, salinity, interference, and battery instability. But in the public imagination, the glitches had to mean something. The story spread faster than the science. By contrast, geological analysis takes time. It requires sampling, microscopy, compositional studies, and comparison with regional bedrock maps. Scandinavia's crust is dominated by ancient Precambrian rock formations, some more than 1.8 billion years old. Granite and gneiss are abundant across Sweden and Finland. The Baltic basin was heavily sculpted by the Fennoscandian ice sheet, which transported massive rocks and carved grooves across the landscape during repeated glaciations. There is nothing in the Anomaly's composition that contradicts this history. And yet, for many, the natural explanation felt unsatisfying. Why? Because ambiguity is powerful. When data are incomplete, the human mind does not like empty space. It fills it. And yet, the Baltic Sea remains mysterious in legitimate ways. It is one of the world's largest brackish water bodies, covering about 377,000 square kilometers. Its average depth is roughly 55 meters, but it contains deeper basins, such as the Landsort Deep at 459 meters. Thousands of shipwrecks rest in its cold, low salinity waters, preserved by limited wood-boring organisms. Archaeologists continue to discover vessels from the 17th and 18th centuries in remarkable condition. The region's post-glacial rebound continues to reshape coastlines at measurable rates, in some areas up to 9 millimeters per year. There are genuine scientific questions about its ecology, oxygen-depleted dead zones, and sediment chemistry. The Baltic holds real enigmas, but mystery alone is not proof of the extraordinary. Extraordinary claims require extraordinary evidence, as astronomer Carl Sagan famously said. In the case of the Baltic Sea anomaly, no such evidence emerged. No impact markers, no artificial materials, no structural engineering beyond what fractured bedrock can naturally produce. The weight of geological context, compositional analysis, and glacial history aligns consistently with a natural origin. What changes everything is not that aliens did not visit. It is that we watched, in real time, how a technological artifact, a sonar shadow, evolved into a global legend. Science is slower than speculation, but it is with science that the reality lies. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.